Hello Math 1 students. This video is going to cover two standards. The first standard is going to be I can determine if a table, graph, or relation is a function. And then the second one is I can determine the domain and range of a function. Now before we really dig into the definition of a function, we're going to talk about what is a relation. And a relation is basically a set of ordered pairs. Basically, it's a bunch of ordered pairs, right? And these relations can be shown in a table, set notation where you'll see like set notation with a bunch of ordered pairs in it, right? It can be shown in a graph and all that. So when we talk about these relations, how does that relate to what we call a function? And what you have to understand is a function is a relation such that for every input, there is exactly one output. And anytime we talk about inputs, right, inputs are always going to refer to the x values or independent variables. And if we're given a function, it's the value of the variable you plug into the function, right? And anytime we talk about outputs, we're talking about the dependent variable or the y value, right? And this output will be the value of the expression after we evaluate it with the given input. Now, so basically to redefine this in, probably an easier way, a relation such that for every x value, there is exactly one y value, meaning, right, there are no repeating x values, okay? Now, with that in mind, functions or relations, right, they have what we call domains. And domains are basically the set of x values. And the range is the set of y values, okay? Now, if the function is discrete, right, we would list all the x values in set notation. If it's continuous, right, we would use interval notation. And the same goes for the range, right? If the function is discrete, we would use, set notation and list each item independently. If it's continuous, we would use interval notation. So let's look at a couple of examples here. The first part is a mapping diagram here. And a mapping diagram basically is a diagram that pairs each input with an output. And if we look here, the column on the left is your set of inputs, and the column on your right is going to be the set of outputs. Now, when we look at it, we want to first determine if it's a function or not, and then the domain and range. So when I look at this, to determine if it's a function, I'm going to look at these inputs. And I don't want more than one line, right, going from an input to an output. So this has one output, this has one output, this has one output, which makes it a function. And since this is discrete, we're going to use set notation to describe the domain, and the domain is just a set of inputs or x values. So it would be 3, 5, 9. Now the range is going to be our set of outputs. So we would write set notation 0, 4, 6. Okay. Now when we look at letter B, right? This input has one output. But when I look at the input 5, it has this output and that output. So because, right, this 5 has two different outputs, that is not a function, right? So because it goes to 7 and 5, it's a big no-no. Now we could still identify the domain and range here just for practice. So we'd say the domain is a set of inputs, so 3, 5, 6, 7, and 9. And the range would just be the set of outputs, which would be 3, 5, and 7. All right, and to go through this one, if I look, each of these inputs has exactly one output, right? So when I look, that would be a function, and our domain would be 0, 1, 2, 4, and 8. And the range would be 1, 6, 7, and 9. All right. Now, tables. Tables are really no different than mapping diagrams, except you have to understand the left-hand column is a set of inputs. The right-hand column is a set of outputs, right? And basically what we actually get here is a set of ordered pairs. Like this ordered pair would be -2, -3, and so on. So when we scan down the set of inputs, we look to see if there are any repeating x values. So we go from -2, -1, 0, 1, 2, 3, 4. There are no repeating x values. Therefore, this would be a function. Now, if it is a function, the domain would just be the set of inputs. So -2, -1, 0, 1, 2, 3, and 4. Now, the set of outputs, right, would be our range. So all I'm going to do is take this column, right, and write each element inside set notation. So -3, -1, 1, 3, 5, 7, and 9. Okay, how about the second one, right? When we look at the second example, I have -2, -1, 0, 1, 2, 3, 4. Do any of my x values repeat? No. Therefore, yes, that is a function. My domain is pretty simple. -2, -1, 0, 1, 2, 3, and 4. Okay? And my range will just be the set of outputs. Remember, it's all right for the outputs to repeat. So 0.44, 0.67, 1, 1.5, 2.25, 3.37, and I'm running out of room, 5.06. All right. Now the last one here, if I look at the set of inputs, right? 4, 1, 0, 1, right? Right away you should notice, right? These ones repeat, but also the 4s repeat, telling me that's not a function. Now for practice, the domain would just be 4, 1, 0, 9, 16. We try not to write the repeats. And my range then would be -2, -1, 0, 1, 2, 3, and 4. Okay, so it's very important to know you look for repeating x values. Okay, the last table here, when I look, Tom's age, 5, 6, 22, 24, 26, 29. None of them repeat, right? So remember, this would be your input. This would be your output. So yes, it is a function. And your domain would just be the 5, the 6, the 22, 24, 26, and 29. And then my range would be the set of outputs or Chuck's ages, which is 9, 10, 26, 28, 30, and 33. Now, these are what we're talking about relations, right? When you look at this, this is a bunch of ordered pairs written in set notation. And these brackets are what tell me they're in set notation. So what I'm going to do to determine if it's a function or not, I'm going to look at each x value in the ordered pair. And as soon as I see one that repeats, I know right away it's not a function. So since 1 is represented twice and it has 2 different outputs, this would not be a function. Now to practice with the domain and range, right away, the domain, all I'm going to do is look at each ordered pair, right? And identify the x values. So I'm going to go -2, 0, 1, 2, and then 3. And now my range, I'm just going to go ahead and write down corresponding y values. Okay, so the range of this function would be 2, 5, 6, 7, -1, and 2. Okay, when we look at the second one, right? Look at my x values, 0, 2, 3, 4, 5, -5, right? None of them repeat, so it is a function. And right away in my domain, I'm just going to write the x values, 0, 2, 3, 4, 5, and -5. And then my range would be 1, -1, 2, and 3. So since you have repeating y values, you only represent them once when you identify the range. Technically, right, I can get picky and say to just write these in numerical order, right? But just trying to get through this in a timely manner. The letter C, right? When I look at if this is a function or not, right away, you have repeating zeros, right? So when you input 0, you get output -5. When you input 0, you get output 4. So one input has two different outputs, which makes it not a function. Now, the domain, right? If I go and look, I'm just going to go ahead, 0, 1, 2, right? Then 0 again, -5, and 3. And my range would be -5, what would that be? 2, 3, 4, and 6. Okay, so when I look at this, this is finding the domain and range of a relation. Now, to determine if a graph, right, is a function or not, what we use is what we call the vertical line test, right? And the vertical line test is if a vertical line can be drawn to intersect the graph 2 times, it is not a function. So when I look, if I draw an infinite number of vertical lines here, do any of these right cross the graph more than once? No. So therefore that would be a function. Same here. If I draw all these vertical lines, each vertical line only intersects one time. So this is a function. But when I look at the third one here, this vertical line intersects the graph more than once. Therefore, it is not a function. And the same here, right? This would not be a function. Okay? So now this is where we talk about when we look at the domain and range of these. If the dots are connected, meaning it's continuous, right? We would write our domain and range in interval notation. If they are just a bunch of points in the coordinate plane, we would go ahead and use set notation and write each element independently. So right away when I look at the first one, is this a function? And if I look, does it pass the vertical line test? And it would, right? There's no vertical line you could draw here that would intersect the graph more than once, so that is a function. Since this is continuous, right? Where does this graph start on the left and where does it end on the right? Well, because these arrows point down into the left and down into the right forever and ever, this technically starts at -infinity and goes all the way to positive infinity on the x-axis because it'll cover every x value. So we say, round parentheses, -infinity to positive infinity. However, my range, right? My range, anytime we write the range, we want to work, right, from the bottom to the top. So where does this graph start on the bottom? Well, if I look, both sides of the graph are pointing down forever and ever, right? So it's going to start at the bottom at -infinity, and it's going to go all the way up and stop right? Where does it stop? At -3. So we would say the range of this, right, starts at -infinity on the bottom, goes all the way to -3 up top, and since -3 is on the graph, we're going to use a square bracket. Next one. Right away here, if I look, does this pass the vertical line test? And if I draw this vertical line, it intersects the graph 2 times. Therefore, it's not a function. Now, if I were to describe the domain of this, right, this arrow and this arrow point to the left forever and ever. So we know on the x-axis, it's starting at -infinity, and it'll travel all the way and stop at this x value, which is 4. So we're going to say their domain, it starts at -infinity, and goes all the way to the right, and does not go past 4 on the x-axis. And that's going to be a square bracket. Now my range, right, since this arrow points down forever and ever, it's going to go from -infinity, and if we follow it all the way up, and this arrow points up forever and ever, it's going to end at +infinity. So -infinity to +infinity would be my domain, or range, sorry. Now here, does this graph pass the vertical line test? And if I draw all these vertical lines, right, none of them intersect the graph more than once, so yes, it is a function. It passes the vertical line test. Now, when I go to find the domain and range, this arrow points to the left forever and ever, doesn't it? So if it points to the left forever and ever, isn't it going to start at -infinity on the left? And if we follow this graph all the way down to the right, what x value does it stop at? And that would be, so these are in 2, so it would be 2, 4, 6, right? So it goes from -infinity and stops at 6. And since it's a closed dot, it's a square bracket. Now, if I look at the range, okay, if I look at the bottom, right, this graph, the lowest point it hits, we're just going to put -10 there, right? So it starts at -10 on the bottom, and we're just going to put a square bracket, sorry, because it's included. Now, it goes a little bit beyond that, but to make it easy, we're going to say it starts at -10, and if we follow it, that this arrow tells us it's going to go up forever and ever. So it's going to start at -10 and go all the way to +infinity. Letter D, does this pass the vertical line test? And the answer is yes, it does. Now our domain, where's this graph going to start on the right? Since it's a closed dot on -4, it's going to start at -4 and it's going to go all the way to the right forever and ever. So the domain would be, starts at -4 on the right, goes all the way to +infinity, or -4 on the left, into +infinity on the right. The range, however, it starts, the lowest y values at -3, and if I look, that'll go up forever and ever, so the bottom would be -3, all the way up to +infinity. Okay? And finally, this one. If I look, this graph right away passes the vertical line test, therefore it would be a function. The domain of this, where does it start on the left? Well, starting at 0 on the left, and if I follow this graph, that arrow tells me it's going to go to the right forever and ever. So the domain starts at 0, and since we follow it and we see that arrow pointing to the right forever and ever, it's going to go all the way to +infinity. Now, when I look at this arrow, that arrow will point down forever and ever, won't it? So although this looks like it's the lowest point, when this function continues like this, right, that means it's going to start at -infinity on the bottom, because it's really starting, it's going to go down forever and ever. But when I look at the highest value it reaches, right, isn't this the highest value it reaches, which would be at 10. So it would go from negative infinity all the way to positive 10. And what the range is basically saying is every y value in between negative infinity and 10 is represented on this function. Go ahead, try the student practice, and let us know if you have any questions.